Alright, so this video will focus on 6.4 and 6.4 extension. And the very first thing we have to do is go through various shapes and kind of look for the functions that make them work. We'll start off very easy in looking at the perimeter and the area of the various rectangles listed. So pause and find them out and then press play and see if you're correct. Alright, so here are the various answers. And we want to recognize when a pattern is in real life is linear or if it's non-linear. So if we go through here and we looked at this here, and we want to figure out the perimeters of these various shapes. I have x and 2x, and if I plug in a 1 for this, my perimeter, of course, would be 6x, right? So it would be 6, and then 12, and then 18, and so on. And that would be the perimeters. The areas, however, would be like 2 times 1, which is 2, and then 4 times 2, which is 8, and so on. And this would not be linear. We'll look at other examples where we have like a falling parachute jumper here, or we have a falling bowling ball, and we're going to look to see if these are linear or not. And in this one, if I look at it real fast, I can see that I started off at 300, and then I went to 285 and 270, and this is actually a very linear pattern that's occurring right here. This one here, if I look at it, here I'm going down by 16, but that's not what's going on here. So this bowling ball is reaching terminal velocity, and when it does that, it's going to have a parabolic function that it will form. So is this a linear or nonlinear? All right, if we look at it, it is definitely linear. For this one here, is this linear or nonlinear? Again, I graph it, or I can just look for the differences. And when I do that, I notice that it starts off, it looks like it's linear, but then it kind of curves up. So this is nonlinear. This one here, it's going up by 10 and then down by 5. And so these are definitely nonlinear. This one here appears to be going up by 5 every time. So it's linear. And then here are a couple other examples that I want you to kind of think about. Are these linear or nonlinear? When you look at them, this x increases by 8 and the y increases, or decreases by 8, I'm sorry, and the x increases by 3. This one does not have a steady pattern, so this is linear and this is nonlinear. If I look at the graphs, this is a linear graph because it forms a straight line. This one is not linear. Then we have to go through a few more examples and see what these look like here. So here are my 3 different examples, and I want you to pause the video and figure out if you think they are linear or nonlinear. I look at the first one, it's definitely linear. This one here is also linear. This one is not a straight line. It's 2 lines, but it's not a straight line, so it is nonlinear. So which equation here represents a nonlinear function? This is linear, this is linear, this is linear. When I divide by a number, that's an inverse variation, so this will not be linear. So C is unfortunately not right. So is this linear or nonlinear? We go through these, you can tell which one. So of course this one is linear. This one is nonlinear because it has this little exponent up to the side here. And here was a practice sheet that I gave out in class, which is a really good example to see if you could understand whether things are linear or nonlinear. And that really is the whole lesson for 6.4 and 6.4